Hi friends, welcome to Joy of Life. Today we are going to solve a Leetcode problem, medium problem, container with most water, which is the problem number 11. But I highly recommend that you try to do it yourself before looking at the solution. The problem is very simple. The problem says given n non-negative integers a1 to an, where each represents a point at coordinate iai. N vertical lines are drawn such that two endpoints of the line I is at iai and I0. Find two lines which together with the x-axis forms a container such that the container contains the most water. So basically the problem is very simple. So we are given few lines, bar graph kind of line, and in this case we are given 186258487, and each of this along with its next value forms a container, right? So in this case this is a container, this is a container, this is a container, this is a container, this is a container. So what is the maximum amount of water that can be filled? So in this case, you can see here that these two guys, the one at the last and one at the first index, forms the biggest container wherein we can have most of the water. So let's take this problem into whiteboard and see. So here you can see that we have several containers over here, right? Let me get the pen. So this is a container. This again is a container. This is a container. So all of them are containers, right? So one easy way to do it is using brute force approach. So what it will basically do is for each value of I, so let's say I starts at the value 1. I'm not talking about the index, it's the value. So the first, so let me put it over here. So we have the value 186254837, right? So for I, we will compare that 1 and 8, how big a container it forms. So 1 versus 8, then 6, then 2, then 5, then 4, then 8, then 3, then 7. So for each one of them, we will see how big a container we can form. And what we'll do is we'll store the max. And again, I moves to the next index, next value, which is 8. We'll consider only the values after I. So we'll check with 6, 2, 5, 4, 8, 3, 7, so on and so forth. So for 6 also we'll do the same. We'll check with 2, 5, 4, 8, 3, 7, and so on. So basically how this solution will look like is, so we'll have a for loop where I starting at 0, I less than, say, A is my array. So let's call it out as A. So a dot length and I plus plus, and the j, which is the next one, the next values. So this one. So this will start from the next index of I. So j equals to I plus 1, j less than a dot length, and j plus plus. And we have a max, which is a int, which is set to 0. And at each step, we will check. So we can just say that we'll do a math.max to check if my max is greater than my current. So what we can do is current we can define over here, and in current what we are doing is we are just comparing, right? So let's say it will be something like a of when we are comparing these two, let's say 1 and 8. So 1 and 8 can form a container which is a height of only 1, right? It cannot be of this side because all the water will spill over here and only one unit will be stored. So basically what we need to do is we have to, I'll discard this. We have to take a math.min of a of I and a of j. So in this case, you can see 1 and 8, I have to take the minimum of these two. That will be the container's height, right? And we will be doing a into j minus I, right? So j minus I will give me how far I have to go. So when I have 1 and 8, so j minus I is basically 1 minus 0. So it will be 1 unit. So 1 unit. So when I move to 6, when j increments and goes over here, in this case what will happen is it will be 2 minus 0. So I can store 2 unit, 3 unit, 4 unit and so on. And anytime we see that the current max the current is beating our max, we update our max. So what we are doing is for every element we are checking the entire array once again. So this will give me a complexity of we are iterating it at n square. So this is not a very good solution. So we will look at a solution that is more efficient and that can run in an order of n times. So the intention would be to iterate over the array just once. So let's look at the solution. So what I'll do is I'll get rid of this and let me get the diagram back. So what I'll do is I'll copy this and paste it. I'll put it by the side and let's close it. So our intention would be that we will have 2 pointers. So let me put it over here. So we have the left pointers and we have the right pointers. And of course we need to keep a track of our max. So the left pointer would be starting at the left, obviously, which is the 0th index, and the right one will start at the length of the array, the rightmost index. So in this case we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements over here. Right is 8, and the formula would be something like we will, as we have seen in the earlier problem also, that we will consider only the minimum value of the two. So if my array, let's call our array as this height array as A. So we will take the minimum of A left and A right. The formula is pretty much the same as we have used earlier. And then we have the right minus left. And let's see how this formula helps us. So the value at left is 1. So this is our current index 0 and 8. So the current so let me put the pointers over here for easier understanding. So this is my left and this is my right. So we will take the minimum of 1 and 7 and we will have right minus left. Right is at 8 and this one is at 0. So minimum, why we are taking, because again we can, when we have 7 and 1, we cannot have a container of size 7. So if you pour water it will go out. So we can only have this 7. So right minus left is 7 into 1 into 1 multiplied by the distance between the two. So here we have the right sitting here and the left sitting over here. So we will take the distance. So it is right minus left. So right minus left is 8. So the answer is 8. So our current max as we say is initialized to 0. We have a value of 8 now. How we got this 8? So 1 unit here, second, third, fourth, fifth, sixth, seventh, and 8th. So this is our first iteration of the loop. So what we got, a value of 8 and which is beating our max. So we'll take 8 as the best answer. Now it's our time to move our pointers. So always the left pointer will go this way and the right pointer will go the other way, this way. So right will always decrement and the left will always increment. So what do we do now? Do we increment or do we decrement? So should we move left or should we move right? So we have seen that right is smaller. So it has no chance of creating any bigger containers. sorry, left is smaller and it has no chance of creating any bigger container, wherein right is bigger than 8 and it has a chance. So if in the next index, if I find something bigger than where my left pointer is, I can create a bigger container. So we will check who is smaller of the two. If the left is smaller, we are going to increment left. If the right is smaller, we are going to decrement right. So in this case, what we see that left is smaller. So we are going to move left. We are going to increment left. Now left comes to the index 1 and right remains at the index 8. So again, using the same formula that we have used, now we have a value of 8 over here, right? So we take 8 and we take the right one is sitting at 7 and we do 8 minus 1. So minimum of 8 and 7 is 7 and 8 minus 7 is 7. So we get 7 into 7, which is 49. So, and as you can see that it is currently beating the max that we have, which is 8. So I'll take 49 as my max because it is exceeding the value. Now we are at a point wherein the left is smaller than the right. So in this case, what we'll do is we'll decrement the right. So the right moves towards the left. So this remains at 1 and this index changes to 7. We have decremented. So again, going by the same formula, we have 8 and we have a value 3 and we have 8. No, it's no more at 8, it's at 7. 7 minus 1. So we see 8 and 3, the smaller of the two is 3 and 7 minus 1 is 6. 6 into 3 is 18. So how we are getting this 18? Let's see in the diagram over here. So our container is, it is sitting here and this is sitting here, right? So the max container that we can get is this. Sorry, the line isn't straight, but you got the point, right? So the height is 3. So each one will have 3 units. And we have 1, 2, 3, 4, 5, 6. So 6 into 3, 18 is our answer. And it does not beat the current max that we have in hand. So it will still remain at 49. Okay, so I have drawn too much over here. Yeah, so what happens is I is sitting at 1 and this guy is sitting at the index 7. So 7th index value is smaller, so we move the pointer towards the left. So left is now at remains at 1 and the right comes at 6. So now we have both the values 8 and 8 and we have 6 minus 1. So 8 and 8 is 8, 6 minus 1 is 5. So we get 40. So here, if we take this whole container as a whole, so each unit can hold 8 units of water and we have 5 such blocks. 1, 2, 3, 4, 5. So it does not beat our maximum. So we'll continue to remain at 49. See, now you are both the values are same, so you can either increment this or you can decrement this. It's up to your logic. Both will yield you the same answer. So let's say we increment this time to this index. So increment left, and here we have 6. So now we have a new value at left, which is 6, and we have 8 here, and we have 6 minus 2. So lesser of this is 6, 4, we have 24. So it does not beat our max that we have. So we continue to stick to 49. Okay, now again the smaller of these two is this. So we increment left. So left goes to 3 and right remains at its spot. So I'm using this side of the space. So again, what happens is we have two values now. The first value is I can't see, where did I mark it? Okay, so the first value is 2, this one, and then 8. So 2 and 8, minimum of 2 and 8 multiplied by 6 minus 3. So we get 2 into multiplied by 3, which we have 6 here. So it currently doesn't beat. So the smaller of the two is the 3. So we increment the left. So it goes to 4. This remains at 6. So this is 49. Okay. So again, we have a new value, which is 5. And we have 8 already. And we have 6 minus 4. So this is 5 and 6 minus 4, 2. So we have 10. So it's still not beating our best answer. So we'll stick to 49. Now, similarly, the I goes to 5, left goes to 5, and the right remains at 6. So the two values over here would be 4 and 8. So we get 4 over here and 6 minus 1. So we have 4. So it still does not beat. Now going by this logic, what happens is the I continues to increment. So it goes to 6 and this is also at the 6th index. So this becomes our termination case. So we can say that left should be always less than right. So the left comes from this side, the right comes from this side. The moment they touch each other or crosses each other, this is our termination condition. And we have our final answer sitting at the max. So now let's see how it will be coded. So let's go back to Leetcode, and it's a pretty straightforward solution. So as we have discussed, I'll just go by what we have discussed. So we'll name the variables also accordingly. So I'll have a max and I'll have a left. Left is pointing to 0 and the right is pointing to so since it's an array, so I have to do a -1. So now we just talked about the termination condition. So the left should be less than right. So this is my termination condition. And at the end of this, when we come out, exit out of this loop, we'll have our answer in max. So here also the calculation is very straightforward. So in our solution, you saw that we are doing a calculation and finding an answer for every iteration of the loop, right? So let's call this current. So let's say current is equals to, so we said that we will take the minimum of height left and height right, and we are going to multiply it with right minus left, right? So we have the current value, and at each point we should update our max if the current is greater than max. So for we can simply write max is equals to math dot max of my max and current. So whatever is higher between max and current, we are going to assign it back to max. Now this is our core logic, and now we have the increment of the left side or the decrement of the right side. So if my left is higher than the right, so let's take a scenario over here. When my left, so when I say my left is higher than right, so in this case left is higher than right. So let's take these two index, this one over here and this one over here. Okay, so in this case what we thought, in this case we are going to decrement, or decrement the right. So right is going to decrement. So again, let's take examples. For instance, this, sorry, for instance, this and this. So in this case, we can form a container which is this big. But my left is higher. I still have potential. I move the right pointer. So the right pointer comes from here to here, right? So we are going to do the same thing. So in this case, what we are going to do is we are going to decrement right. And otherwise, sorry, this will be over here. Otherwise, what we are going to do is we are going to increment left. So other means when the right, for example, let's say we have a scenario over here. So in this case, this one and this one. So in this case, what we are going to do, we are going to increment the lefts. So this is where my else condition will come into play. So let's see how it goes. Yeah, so it is accepted. Let's submit and see how it goes. So you can see that our solution takes about 5 milliseconds and it is faster than 31%, and the memory usage is 49.7, which is also accepted. So this is my simple solution to the left to the problem container with most water. Do let me know what you think about it. I find the solution to be very simple, so thought of sharing with you. I'll be sharing more videos in the days to come. Do subscribe if you haven't done so. Share and like as well. I'll be creating more videos. Thank you for watching. See you soon. Bye bye.